Hi, my name's Chris Ellick. I'm a product manager here at Nakina for NI Guardian. And NI Guardian is a product that helps secure carrier-grade mobile networks, so today's 2G, 3G, 4G networks, as well as tomorrow's networks based on NFV and SDN. So, at this point, a lot of the background work has been done on NFV and SDN by groups like Etsy and amongst others. And, a lot of the business cases have been done to prove that the technology is viable. And, a lot of the POCs and everything have been done to outline how the mechanisms are going to work. But the details have not really been worked out around security. So we're kind of moving now from the basic operational use cases to really starting to think about, what's going to be involved in locking down these networks. They provide certain advantages, so things like denial of service. There's an expectation with that NFV, SDN, there'll be new mechanisms to mitigate denial of service attacks by spinning up new resources as required, but these networks also pose some new security challenges around multi-tenancy and a number of other things. So we know today that some of the leading causes of breaches and network security surround the protection of privileged accounts, right? So this goes for both the malicious insider, right? So rogue sysadmins, after they've been giving their notice, sometimes leaving logic bombs. I mean, there's a couple of high-profile cases you can Google on that, as well as inadvertent use. So people accidentally giving up their credentials, and of course, there's other things such as protecting against your vendor access, providing your suppliers with privileged root access into your networks. I mean, you want to lock these sorts of things down. So one of the things we do know with these new architectures around NFV and SDN is that the security risks will increase. So, we have with the NFV architecture, we have a number of different areas we have to protect. That goes all the way from the network function and virtualization infrastructure, right? So the actual physical compute, your hardware, your storage, CPU. And then on top of that, we have our OS level and our virtual machines. And then on top of that, we have, our network function virtualization NFV instances. And this is going to be a multi-tenancy type of situation, so you have to have instance-based security across hardware, across OS, across virtual machine, and the NFV instances themselves, as well, of course, of your management and orchestration layers. So it's important that you have processes to provide and grant access, to monitor access, to audit and log access. Here's a case of use case around a multi-tenant, multi-site NFV-based mobile backhaul. So in this case, of course, you have to have, as it says, your domain isolation and access controls around your virtual network forwarding, virtual network functions, your NFV instances, and of course your management and orchestration layers. In this case here, if we have two separate mobile network operators, we can have MNO1 and MNO2, and both of them have different NFV instances on a single piece of hardware. So it's important if, for example, if you were to configure a probe in your network, you have to have security around the creation and instantiation of that probe, who has access to it, and you have to be able to log all of the activities that go on in this network. Whether this is, you're talking about machine-to-machine communication or with any human intervention. The other thing that's important here is, and this comes to both any kind of post-mortem activities that happen, as well as in real time in your NOC, being able to create actionable intelligence and being able to correlate, any kind of fault events with security events in the network. So, you want to be able to log and audit any of the activity that occurs in the network, who accessed it, what did they do. This is important for both understanding, any security breaches that happen, being able to have full traceability back to, what machine accessed what network resource, what person accessed the resource, what commands did they execute, and you want to have sufficient proper permissions and authorization privileges to make sure that minimum privilege is adhered to. And of course, any solution that you do come up with, let me just go back. It's key that any solution you come up with for securing both the next generation NFV SDN environments has a way of coordinating with any configuration in the legacy physical networks. These established networks, of course, are not going away. So a typical use case that involves, say, something like a virtual, whether it's a virtual CPE or, something related to your radio access network with eNode Bs and so forth, you're going to have coordination between those virtual elements and physical build as well. So Nikina's products here, product suite includes a number of different items. So over here on the right, we have NI Guardian, which is the product I'll say a few more words about now. So NI Guardian secures privileged access to mobile networks. NI Director does provisioning and activation. NI Collector does inventory data reconciliation, so between the data in the network and OSS tools such as Netcracker, Granite, etc. NI Controller does gold standard audits, so between the profiles and configuration you have in your network and a master gold standard. And NI Creator helps to create new service models. So we have a business layer or framework that's common between all of the products to help with things such as bulk network discovery, node discovery, and processing. And at the bottom, we have a adapter library to help you plug into the different pieces of network equipment. So here's kind of a simplified architecture of the NI Guardian Identity and Access Management solution. So we provide role-based access control to both the physical and virtual network functions. So this makes sure that you have instance-based security for your entire network, adhering to the principle of least privilege. And basically the way NI Guardian works is we create a wall between the user credentials and the network credentials. So a user logs into Nikina with their username and password, and that could be either against our internal database, could be two-factor using Secure ID, could be an external LDAP or Windows Active Directory server. Doesn't really matter. There's a plethora of methods for accessing Nikina. Once you're into Nikina, we understand all of the details around a particular user's privileges and permissions. When a user requests access to a particular network resource, we will, if they have sufficient permissions, we'll log them onto the network on their behalf with a username and password that is unknown to them. We'll fully log that activity. So in the case of EMS OSS access, we'll have a video log of that activity, which is, by the way, all of the UI events are fully indexed, so you can do text searches on video logs. And for any CLI access, we'll have text logs for those activities that are searchable as well. So again, that's important for any standards-based certifications, whether it's local government requirements or industry standards such as PCI. We'll have compliance amount around many of these standards, along with complete audit and reporting. Here is just a customer example and use case. So at Bell Canada, we had a couple of different projects. One was around PCI, payment card industry compliance to protect credit card information, and the other was around vendor access. So typically vendors need to access the network, but you want to do so, again, following the principle of least privilege. So if vendors need to get access with, say, for example, a route during a maintenance window, you'll want to be able to provision route at the start of that maintenance, provide them with privilege escalation at the start of the maintenance window, and at the end of the maintenance window, you want to have them automatically knocked down back to regular user. And of course, you want to have a full audit trail of who did what they did, and when. I'm not going to talk about all of the details. You can read for yourself here. A few more of the details about the particular use case. And I guess just here in some of the summary here. So with network function virtualization and SDN, it creates a number of new security risks and challenges. So number one, I think here is multi-tenancy, right? So it's important to have instance-based security around both human access and machine-to-machine. Of course, with the NFV world, we expect machine-to-machine communication will be the norm. Humans aren't going anywhere. Humans will continue to access the network. But in an environment where a lot of the configuration activities happening in the network are happening in an automated way through machine-to-machine APIs, it's more important than ever to have, to be notified of security events and challenges. So you need a full audit, and you also need actionable intelligence around when, something awry is going on. So again, it's very important to have, policy management rules, and good forensics. For example, if maybe a particular account is being used, for an activity that it wouldn't normally be used for. So maybe particular commands, particular protocols, maybe high data counts. Because all of this is going on in the background in an automated fashion, you want to have forensics and to flag anomalous usage. Roles and responsibilities. So, this will be a siloed environment, right? Again, we have multiple layers of security to police here. We have physical, we have OS, virtual machine, and NFV instance. That's a lot more complex than, a hardware appliance like a Cisco router today, where it's all in one. And I think I've talked about some of these other items. So I guess just here in terms of parting thoughts, right? So again, we've really hit the rubber. The rubber's really hit the road here with NFV around the basic business use cases and cost savings around the operational models. But we're really only now getting into the details of securing NFV. All of the instances and really thinking about how this is all going to play out. A very flexible access management strategy is needed here. So again, it has to be instance-based. You have to have mechanisms in place for access approvals. You need to take into account both human beings and the more dominant mode of operation with machine-to-machine communication. And you have to have a solution that will be able to span both the existing legacy networks, right? 1G, 2G, 3G, 4G. These networks are not going away. this equipment's going to be around forever, and being understand to have a solution that can span both the legacy networks of today and the virtual networks of tomorrow. And yeah, I guess now we can have start our stick around for a demo if you're interested.